But I'm curious. You said you're a fresh grad. What does that mean?
I graduated from NYU in May.
Ah, okay, okay, awesome.
Yeah.
Congratulations, first of
Thank
all.
you. Thank you.
Um, yeah, so for AI in action, it's normally just like anything that's interesting. So I wouldn't, if I were you, I wouldn't feel too much pressure to perform. As long as you're talking about interesting stuff that's in the AI space, I'm sure, we'll have a good time.
Mhm. Do you find dynamic constitution through RLIF interesting?
Yes, so the transition from like RLHF to I guess AIF to now like they're calling it RLVR, which are all separate things, but like that's like the buzzword of the day or the week has been interesting to me. And verifiable rewards is now kind of like taking on this thing where people are contributing to like a community effort for verifiable rewards. That's that whole space is super interesting to me. So I think this should be a good talk or maybe like a good presentation is like kind of like my thoughts off the bat. But I have not dug deep enough into or I've done the research on reinforcement learning and like how you can use verifiable rewards to make models better for like low cost, but I have not done it myself. So that's something I haven't really explored the way I need to. But I do find it very interesting, that whole space.
Yeah. Long story short, this is my attempt to create my own Jarvis from the Iron Man movies. And I started simple. I just wanted okay, do we have to wait or like should I just begin?
I mean, being that it's recording, we probably could begin. We normally have a few more people come in. Yeah, we have some people joining now. Give it to like 3:05, like 2 more minutes, and then we can go
Mhm.
get started.
Yeah, but that's my take on it. I just want I was applying to jobs and the process got a bit too difficult. So I decided that I'd much rather just use my skills. Why do I need to grind lead code anymore?
Hmm.
So I just started simple. I wanted to have dynamic gaming banter more or less. Like in-game characters talk to me instead of just to the game,
Yeah.
or I interact with the game more or less. There was this idea in the latent space Discord where people say that basically more or less we don't have dynamic NPCs, right? We have pre like NPCs which have pre set amount of responses.
Hmm.
So I just wanted to start simple, and that's where I began.
Yeah, that's pretty cool. That's a cool idea. I like the idea already. Zach says I'm doing Claude as coach while I work on a couch to 5K program. Another training of the mind and body. Yeah, that's pretty cool.
Yeah, I haven't really gone the like Jarvis route, but like it's not that. Like I've got my own version of this that I'm exploring. Like this is an interesting space because like the models have gotten cheap enough and powerful enough that like wrapping something around it to help like whether it's I need to figure some stuff out and I want to like bounce some ideas against these different personas and have this kind of conversational space, or it's like I just need someone to be like, yeah, it's fine that you're blocked. Go walk for 5 minutes. That like part of my brain that I've had in the past, but
Yeah.
it's like easy to lose track of, and then you just like stall out on stuff when you could easily just go touch grass, come back, and then get back to it. And I need that little external reminder system. And like I'm just using Claude for it because like 20 bucks a month in a web chat with the right project context, like it works. But I've been wanting to like evolve it into something a little bit more like structured. So I'm curious what you've got to share with the group.
Hmm. Yeah. Hmm. Okay.
Yeah,
Okay.
we
Okay.
probably it's 3:05 now, so we probably can go ahead and it's recording, so we could probably go ahead and get started. I'm curious about the voice part of the Jarvis thing, but yeah, I think we're clear to get started now.
Yes. Okay. Just a minute. So basically, like as I said, my idea began with something that I wanted to email Gabe Newell, the owner of Steam, and I just wanted to start with gaming banter. And it started with Banter Packs. Basically, integrate an LLM, get to a system where you have a prompt engineered character talking back to you through the game. I had everything mapped in. I started figuring out like the in-game mechanics as to what DLLs needed to be tracked so that the local LLM could respond. Initially, it was just text. Once I had the MVP ready for text, I tried to overlay it over the most recent Alien game. It was launched. I took it and I pushed it over the Alien game's trailer, and it worked beautifully. Then I injected it into the game. I could figure out what DLLs I needed to track to just see what events were happening. And then, like once the characters started moving or their lips started moving, my LLM started responding with through text. Now I used Whisper plus Piper for the entire conversation to be tracked. So whenever I responded, instead of I muted the in-game characters and I had the system respond to me. This is the Banter Packs aspect of it. I had a real-time streaming overlay through OBS. OBS tracked my entire in and out and offered it to the local LLM through Llama. That was where it initially started. Now, here is where the problems began. The first layer, while being Banter Packs, is that there's a lot of latency. Whenever there's a local LLM responding, your TTFT goes to about 2.5 seconds, and that's not good. Like if you're playing games, you needed something that could instantly respond. So efficiency was a big problem. And sometimes the LLMs either hallucinated or lost track of the personality they were supposed to emulate. So I had generic responses instead of specific responses. So if I was playing RDR2, sorry, Red Dead Redemption 2, uh, instead of Arthur, I'd get some version of Marvel Rivals character responding to me. That was not good enough for me. So I started digging deeper into the aspect, and the first thing that I found was I moved on to Banterhots. I took out the LLM engine. I created an entire MLOps platform. In that MLOps platform, I started at the basic of layers. This is where the research got interesting. So initial findings told me that if I could use partial offload, I could get better TTFT for tinier prompts. And using full offload, I could get better responses, better TTFT and context loading, only if I keep it locked. The quantization was basically depending on game, so it would understand what I was talking and just load data based of that. And optimizing the throughput is what gave me 10x improvements. All of these reports are in the link that I have put into the chat. And hold on, let me go on further. So all of this Muse protocol is the part how I like publicly publish what is happening in the system, because Anterpacks and Vanterhearts both are private repositories. So Muse protocol takes data from Banterpacks and Banterhearts and publishes into Banter blocks, which is the public deployment of a public site, which tracks what progress I have made so far, everything from the benchmarks to the development process. And in the research phase, this is what I found. So if I used quantization for Llama 3.1b, I had around 76.59 token per second. But with Gemma 3, I could use 100. I could get it up to 102. Optimal configuration came out to be a full offload with context limit of 4096 KB and a temperature of zero point 0.4. So that was the general victory there. Next, I start. Then this is where it derailed completely, because I went off to a competition. There was a hackathon on 4th October, and there were a lot of like OpenAI's startup head of division. A lot of founders were there, and they wanted us to create some product out of a agentic workflow. We were assigned some amount of free uh, API calls, and I sat in that room working with around 150 other people, and I saw like hundreds of dollars just flying out for MVPs, which may or may not be further used. All of this, all of these unique ideas were just flying out, and they were being used in any possible way. Now, this is where I also found out that hundreds of GBs of data was also being read. So anyone, if possible, they were already incurring hundreds of dollars in terms of API calls, costs in terms of API calls. They were also losing data. Their data was being read wherever it was going. Nobody had any idea where it was passing off to. I was talking to people, and yeah, that happened. And I came back from that hackathon. I had an idea that I wanted to implement my local agents. And that's where the Jarvis idea started, that I could use my I had a working voice system. So I could just deploy my agents through through having a conversation with my local orchestrator. and I started working on the agent workflows. Initial findings was that basically whatever I found in TR 108 was irrelevant in TR 109, because any sort of improvement in TTFT that I had failed in multi-turn tasks. So to get that, I had to adjust any for the GPU. I had to take the full offload and reduce it to a partial offload, and the context size had to be reduced, and the temperature had to be adjusted for that. Upon doing that, then my agents got more faster and had a better, slightly better throughput improvement. But the task got done with 100% accuracy, so that worked out for me. The task was basically for the benchmarking purposes. The task was whatever Triton, CUDA, NSYNC uh, benchmarks that I had run, to ingest all of that data and draw inferences from them and publish a report. The template of the report is on my GitHub. It's in the chat. So you'll find the report TR108 there, TR109 there. And the total process ran about 3 hours or so. And then I started building further down the line into concurrency. Single agents deployed locally 100%. So now, how much could I push the system? So I went into, like, I needed multi-turn agents working concurrently and together onto a task. So the task remained same, but they had to, one agent was the ingester and another was the analyzer. And they were coordinating. And I found out that if I had baseline Llama models deployed over LLM, I could get mixed accuracy. The speed up was tangible, but efficiency was mixed. Heterogeneous meaning, like, if I had a specific tuning at the CUDA core level, heterogeneous adjustments due to any sort of specific task. So if the ingester has a specific heat or kernel adjustment, it wouldn't work if they weren't homogeneous. The LLM models offered, the GPU did not offer full offload. So that's why we needed homogeneous, and I found out that I could have a 2x speed up with two agents deployed simultaneously with a 99.3% efficiency boost.
On
This,
12
yeah,
gigabytes of RAM is crazy. You've mentioned a couple times that you posted a link in the chat. You're not talking about the Zoom chat, right?
it is in the Zoom chat. Yes,
Is it Gaben.ai? Is that what Zach posted?
no, hold on, I'll have to check. But I'll just finish this.
Yeah, yeah.
So once I figured this out, then this is where the findings were pushed out. Like, there was a if I had heterogeneous systems, there was a lot of memory contention. So if I wanted a full offload, I had to avoid any sort of memory contentions. So that's where I had to select what sort of partial offload was needed. I'm sorry for this, but I was playing around with Claude, and this is what it generated. I apologize. But the contention was GPU equal to 80 layers is what was the minimum threshold for a stable two agent execution. You could execute more, but it depends on what your VRAM is and what sort of quantization you use. And was normally there's a, depending on the context size, there's no linear graph. The graph is the total findings are very interesting. When I ran both concurrently, single agents could have a specific TTFT and a specific token output, but there is you realize that you can have a full offload only if you adjust context size to be a 4 KB minimum. But for a concurrent multi-agent system, you had to halve that, and then only then you end up with proper efficiency there. And this. This is not it. But beyond two agents, it depends on your, as I said, it depends on your VRAM. And if you have like a proper system with around 50 GB or whatever VRAM, you'll be able to run at least 10 agents concurrently without any contention. And fully local, no need for internet, as long as you have all the data on the system. So what we found out is basically what the total token per second was 102 for Gemma 3. Workflow optimization was pretty much domain specific. So if your task changes, your optimizations will change. For that, I have been working on an optimization agent which detects the task. And that's where the entire RLIF pipeline that I was talking about comes in. And multi-agent concurrency could achieve a theoretical 2x boost. And Thank you. That's about Chimera. I could discuss further. Hold on the RLIF pipeline. But before we go to that, I'll go through the reports once. Uh, so for first things that I was using latest Gemma 3, and I used multiple quantizations for it. Everything I think from 270 million to 1 billion quantization to 3 billion quantization. And general findings were basically if there was one, you could have 165 millisecond mean TTFT with memory usage at 5.3 GB. And these are the parameters. That's basically Llama versus Gemma. I was going to test more, but I found RLAF more interesting. Like the next phase of this is basically what I've done is I'm using API calls from Claude, I'm using API calls from Gemini, I'm using API calls from OpenAI to optimize the performance of my local Gemma. So if I have a task, Gemma produces an output, and the three big names they debate over over the quality of the output and whether it's good enough. If it's not, then they offer. They retweak the output, and then this retweaking process is fed into an RLAI database. So that when I am further training the local Llama model and I have to use RLAIF, this is the database that will help design the PPO or the DPO. Though I haven't quite decided how to do that. Yeah, this report is about like all of these reports are about 100 pages. So if you want to deep dive, it's thoroughly available there, and I'm open to questions. Yeah. Okay.
Do you have enough GPU power to share your screen during Zoom and show us this in action? Is my first question. Can like you show us?
No. I have hit contention issues. Like if I am training, if I am running it out, what ends up happening is it straight up crashes. Like if I have Zoom working. Hold on, let me check. Just a sec.
You fit it in a collab, maybe? It could work. I don't know. I got here.
Colab is on cloud, and I have run out of free credits basically.
What is that's an RTX what GPU?
RTX 4080.
Okay, 4080. I gotta look up the VRAM on that. Yeah, this is really cool. I think just from a research perspective, it's really cool. We had some questions early in the chat if you said you wanted to field questions, but yeah, really interesting research that you've done here. I like it.
Yeah.
Yeah,
Hold on.
because we were curious what machine specs you need. You were talking about running Llama and doing gaming at the same time, and I guess
Yeah.
you're saying that you need at least or in your case, you've used a 4080 to do this to pull this off. And Cam L says which params got you 10x throughput? I think this was on an earlier slide. You were talking about 10.
Yes. So for that, hold on. I'll go sequentially. No, not here. Hold on. So reports, Olama. I apologize. I'm not used to this. So for the deep dive, these are the parameters where I found my initial throughput was 5.51 second TTFT. Sorry, initial throughput was around 7.9 tokens aggregate. And for quantization 4.0, I had 78 increase, and that was 10x. And these are the tunings that I used. It's all in the reports. Okay.
And then one of the other things you mentioned a couple times posting links. I'm assuming this GitHub repository is what you were talking about when you were talking about posting links.
The link was for this report, like this entire doc folder. This is what is being posted in the chat. So anything that you want to test, play it out, it's right there. Like any questions you have related to it.
So in theory, I could go to this GitHub repository, follow your steps, and reproduce this. Like, let's say I have a 4080 at home, and I can reproduce these steps, and also have like a Jarvis on my computer. Is what you're saying?
Yes. You'll need my Chimera optimization. You'll need the Banter repository, but you can end-to-end replicate all of this.
Got it.
So like you'll need this repo. It's not public. It's private.
Oh, Banter Hearts. Okay, I see.
So like this and this repo both are private. The public is Banter Blocks and Chimera multi-agent.
And that's primarily research, not necessarily the agent itself.
Banter has the agents itself.
Yeah.
So hold on. So these are the agents that I ran, the entire reports end to end performance. And then there's multi-agent, same comprehensive test results, phases. I have been selective in uploading all the research, like the data up because that was a lot of stuff.
Yeah.
Like this entire repo is about 200K lines, maybe more. I'll have to check.
Did you get a release plan for some of the? I got here a little late, so I don't have full context, but it looked like you did some like CUDA optimizations and kernel rewrites and stuff. You got a release
Yeah.
plan, or are you doing that?
I did Triton based optimization for which is in kernel deep dives. Just a sec. Going back to that. Okay, hold on. I have it on here. So this is what we found out. I could not do QAT, and that's why I could not be like this is testing around. This is just playing around. But for optimization, torch optimization had a basic this attention for attention kernels. For matmul, this is what I found out. And after kernel fusion, my TTS actual latency went down 10x, 50x around from 6.9 to 0.07 for my orchestrator. So this is all for my orchestrator. Kernel optimization, like I cannot have resource contention, right? The orchestrator for the agents needs to respond instantly so that my multi agents could just go off and do their tasks.
Yeah.
I think he was Yikes was also asking, do you have this is a part of a larger question that I have, but like, do you have a release plan for the CUDA optimizations that you made, the kernel changes?
I do, but this is like all of this I have done in over like the past 30 days. This optimization thing started as I think it's yeah. See, it was just over 15 days ago. So I do have a plan on eventually realizing like releasing a one-click optimization straight up end to end from downloader to everything. But currently, I'm just exploring ideas as to how I can have the entire RLIF AIF pipeline working out, like so that you can have everything optimized for your own personal gain.
Yeah, no, that sounds very, very interesting. Yeah, the possibility of being able to optimize task specific CUDA kernels I think is underexplored. So this looks like a fun kind of spot to be playing around.
Yeah.
Yeah, I'm really curious. Like there's of course the frontier models are like all the, big giant GPU stuff, but I'm personally excited about like smaller models that can run on prosumer hardware. I'm curious why you picked Gemma 3 and not other smaller models. I know Gemma 3 came out a little while ago, but like in AI terms, it's ancient because it was a while ago. But I'm curious, like it looked like you did compare it to a couple other models, or was it just like Gemma 3 was all right,
Gemma 3
cool, let's start
Llama,
here.
and then for like the thing is, Gemma 3 had a lot of documentation already, actually. So people already had performed things and did things with it. So if I do everything with the latest and the greatest, I do not have comparative analysis. I do not have points of reference as to why things are failing. So all of this could be, if I don't have models which I have a historical data, it could just be people actually having optimized originally and my system doing nothing, if it makes sense to you. So I
Yeah, I mean,
optimized Gemma 3
I
and
see
Llama
on
3. Yeah.
I see on Hugging Face that there's like 218 fine tunes for Gemma 3 4B. So like that makes sense why you would be like, all right, this is where a lot of other people have gone. Let me not like blaze a new trail. Let's kind of like follow what other people have done. I'll have more to compare against.
Hmm. It
Yeah,
offers me benchmarks to compare against whether I'm doing MLOps properly. So once I understand that this is what the ground reality is, this is what people are doing, and this is what their understanding is, then I can debug on a level where I have more understanding. uh, I can optimize in a nutshell on any sort of frontier model or like the latest models. But again, that would mean that it cannot be simply me doing it. It could be the person who launched it who has already done it. So what am I doing better? So this is what I'm doing better.
Are there any of the newer models that have caught your eye that you're interested in, especially like from the Chinese labs that have the smaller models?
I recently I read this research paper by Samsung, I think it was the 7 billion model that could perform as well as a 40 billion parameter model. I wanted to test it, but like my research, like this is all the bottoms up. The other optimization technique that I have been like I have written a document on is TD. Okay, this could get interesting. Hold on. So uh, in this, like I am going now for a tops down approach. Mhm.
The other interesting thing potentially to look into, or to follow up on Flo's point, or Zach's point, Gemma is actually a pretty solid pick for this, in my opinion, largely because I think the Gemma architecture has Google has been a lot more oriented around optimizing that for small models, mobile especially, because they're trying to integrate it directly to the pixels. So especially
Yes.
the 3N, I think would be really interesting to do to see if any of these translate over to the 3N, because if you can get more performance out of a 3N, I think you could do like a lot on the edge, which I think this particular architecture would be really, really useful at. So
Yeah, that's what my idea was. Basically, all of the models are generalized. So this is where I started the RLIF. Like if they're generalized, then I can make them special purpose models. So
mhm.
there was this as I said, the RLIF thing. That's what it was for. So yeah, models are tiny, but they have a lot of hallucinations and their accuracy goes down. Oh, being ultimately LLMs are pattern matchers, so they will only pattern match as much as they have in memory. So I'll much rather replace it with task specific memory. Like if you're coding, like you're coding with Claude, you're not going to code in 50 languages. You're going to code in five specific languages, and you need a model that's only special for those five specific languages.
Mhm.
And in those five special languages, Codex is very strong at something, Claude is very strong at something, Gemini is very strong at something. So your end-to-end stack has five languages, it has specializations, and it has specific needs. And that's where this entire RLIF pipeline comes in. Your local model is being trained by these big names to be optimized for your task. The
Mhm.
constitution for this local model is stored locally. So none of your personalized proprietary code is leaked out because you are running agents through your entire code bases. You are running LLMs through your entire code bases. You have no idea what is being stored where. You have no idea what sort of learning is happening and what sort of data prompt injection based leakage is happening. So if you sandbox it onto a local system, you can test end to end and you have no issues. So based on consensus, and I've also optimized like like my current this idea, we can have RLAI for running for end time. Instead of that, what I've ended up doing is I have weight adjusted models. So Claude gets a higher weight for coding tasks, Gemini gets a higher weight for life tasks, and general purpose task OpenAI has a higher weight. So based on that, that's like how the debate works. And what I've done is I have budgeted those debates. So everything has a limit. So if those API calls have a specific cost, I have sandboxed those API calls to $5. So in $5, they must reach a consensus, and they must generate an output, which is very like good for me. This is
Mhm.
good for this task, and that's it. That's the output that I need. I don't need to go back. I don't need to go back and I don't need to check on Codex. I don't need to check on Claude, or I don't need to check on Gemini. So if Gemini, I think today we had that Google launch. I'm not sure, but Google is launching Gemini 3, right?
Mhm.
So I can just plug that in right here, and I can use that for my own optimization.
Yeah, no, that's really interesting in that. So we have frontier models with different specializations, and then if I'm reading you correctly, then we have a RLIF pipeline that is monitoring like per task, and then for each task, we're going to have the various frontier models at different weights depending on the task be doing more or be more heavily weighted during the RLAIF process? Is that kind of the idea?
Yeah.
Sweet. Nice. That's really cool.
So this is like the top-down thing. So while I am optimizing bottoms up, I found out that I have 2x boost. That's enough. Like that's good for me for now. So what I needed to do is if I can optimize from top down. If my local model is performing at least as good as Claude currently, not even as good as Claude, I can say 3. Sonnet 3.5. I've achieved the task that I need. I have two agents running concurrently, fully local, without me having to pay a single cent, except obviously the hardware costs, doing my task for me. And they are obviously going to explore private data. They are going to be sandboxed into an environment where they cannot like send out data, and everything remains fully local.
I guess also cost of electricity and as we're getting colder going into the winter months, your room's gonna be nice and toasty from that GPU running.
Yeah, true, pretty much. But yes, this is not public. Like I can post a GitHub gist somewhere. But like this is a proposal for now, and I have not fully explored this. I started this 2 days ago. I have a current debate working out, but I ran out of API calls, so I'm waiting. But yeah, like that's the idea that I have. Everything is fully modular, so you can plug in any model you want. So sometimes what ends up happening is 3.5 is better at some tasks than 4.1 Opus. So why not use 3.5? They're more stable, 100%. I think someone posted that Codex is giving streaming error. Why not? Then we can just switch to GPT-5.
What's your validation path or like your consensus algorithm kind of set up here? If I'm tracking correctly, we have RLAIF that's happening through some kind of debate format, which is weighted depending on the task. And then there's some kind of termination point that's either $5 or like more or less like, I like it, this works for me kind of thing. Are you driving the model during the RLAIF process so you can get to the validation state and then lock it in? Or what's kind of the process?
So right here.
Let's see. Apply test based pairwise comparison. Okay. Proposal that beats all others is Condorcet winner. There's no okay. I'm not familiar with Condorcet or Borda. I'm presuming that those are just like a scoring
Yes.
algorithm. Yeah, and it's like LLM as judge kind of like preference based stuff.
Yes.
Nice.
Yeah,
Sweet.
that part's really cool.
Yeah.
Yeah, really cool.
But
I was gonna ask, can you get into? I have like some. I think the questions that'll actually help you in whatever journey you're on now. But I'm curious, like Banter Packs versus Banter Hearts, Banter Blogs. Why did you name them that way? Like, what's the significance of the naming?
there's no significance. I was being dumb, honestly.
Yeah.
Like
How do we do
there's no
AI?
significance. I just like
Vibes
this
is
was
what I'm hearing. Vibes.
Yeah, yeah.
yeah. I had like the entire ecosystem is called Chimera, but I started off just because I wanted to, and it's gotten pretty far.
The model optimization is whichever one has the best banters, bro.
Yeah, yeah.
I mean, normally if you see, uh, we had a GPT-3 being robotic, and people didn't enjoy it, so they personalized it.
Hmm.
GPT adapts to your vocal cues, or sorry, the things that you say,
Hmm.
and it speaks in your tone. That's what I'm using.
Yeah,
So
good
this
job.
this is pretty much like personalization on a whole new level, because not everybody is going to be the same type of dev. Not everybody is going to have the same type of life tasks. Not everybody is going to have like specific requirements. Some people are going to be hyper fixated on having deterministic outputs, and some people are good with just arguing through ideas and just exploring them. And the Constitution
So
remembers that. So
so
this debate, yeah.
is this the daily driver for you now? Like, are you using this tuned model for all sorts of daily stuff, or are you still sort of like tuning it and finding new angles? Or is it useful in certain contexts but not others? Because this size can be kind of hit or miss. So I'm curious how like in use day to day it feels?
Day to day, I enjoy it a lot, honestly. Like while I'm chilling, while I'm just thinking through ideas, I go through a back and forth through like hitting this idea, RLAF, and its weightage. I had no, as someone else said, the entire algorithm, I had no idea if that could be used. So I explored through all of these three frontier models together, and I found out that this worked for me. Like this was the best way to handle weights, 100%. So why not just debate? Like normally we have ideas and we have to Google multiple things. So instead of Googling, I'd much rather have the LLM Google it for me and find like specific answers.
See, so we're using weighted voting and ranked choice. Is that so? Are the larger models doing? Are they deciding like what decision are they making here in terms like are they actually doing weight updates?
Not weight updates. They are creating an RLAIF dataset. So
Oh, okay.
normally what ends up happening is question is generated. What is quantum physics? Local model generates an answer. OpenAI generates an answer. Gemini generates an answer. Claude generates an answer. We enter a debate. There are four responses, and which is the best? Why is it the best? Once the debate phase ends, they hit a consensus, and that answer is stored into. I look over the answer. If I say that the answer is good, it's stored away into the constitution, or rather the RLAF dataset, which will eventually be part of my dynamic constitution. But yes, it's stored away, and it
So
keeps on updating until like we hit the repeat part. So if there's enough data, I can train my local model to generate answers similar to Claude for coding, similar to Gemini for daily tasks, stuff like that.
okay. And then where does the like kernel level optimization stuff fit into that picture? I see data set and then I see test train, I think.
So
Yeah.
normally this is where it starts getting fun. I've created a data set where my prompt is what is quantum physics. So that's the size of the prompt, and the data set is going to be generated. So it's going to go onto the GPU. So some tasks do not require a full GPU offload. Some tasks do require a full GPU offload. Now it decides, the orchestrator decides based off the three reports that I have, TR108 through TR110, and plus whatever further research that I find. It decides that this is how much GPU allocation needs to happen in 70 nanoseconds, 70 microseconds, and it offloads onto the GPU. So your LLMs respond as fast as they can on your current hardware.
Huh.
So top down, bottoms up.
Okay, so there's an orchestrator deciding how much GPU to allocate, and that's for each task. And the thing that's being allocated is GPU memory for the small model, and the small model is being, let's see. Is small model actually getting weight updates in here? I don't know, I'm losing it, I think.
It's not getting weight update. It's not getting anything. It's just generating answers for now.
Okay.
It will be further optimized later.
Hmm.
So currently it's just working out, like it's just responding to my questions.
Okay, but so the idea being like there is a GPU scheduler, it has some level of access to this constitution based kind of golden data set, and then since it just has that, it's like infer this and do the scheduling kind of thing.
Correct.
Nice. I like that actually. The
Yes.
the just let go and like get to the point where you understand the interesting steps up until here, and then you're like figure it out. I think that's
Yeah.
I think it's a
I
very
mean,
fun.
hardware is going to change.
Mhm.
I started with 4080, 5090 is already out, 6090 is going to be out by the next year. And I might end up with a A500, I might end up with a H100. If I optimize for each GPU, I'm going to end up confused. I can't do that. So why would I let that happen? I would much rather benchmark whatever GPU I have on hand and then optimize my LLM based for that GPU. So any personal GPU that you have, you can optimize for it.
Mm.
One shot optimization, one shot LLM deployment, one shot responses. So you
In
don't, that's the reason the RLAIF data set is not integrated into the Banter Hearts or Chimera, because this will be your ground truth for your future models. You see, like if you switch devices, if you go from a MacBook M3 and if you go into a MacBook M5 Pro Max, whatever.
Mhm.
So the optimizations are going to be benchmarked differently. But ultimately, what preferences that you have for responses need to be the golden standard for the local model that you deploy. So if you deploy, like I am deploying Gemma 3, you deploy GPT 120B OSS. Both of them are going to have different answers. But your preferences are yours. Your answers are yours. So that GPT OSS 120B needs to know that your life preferences are this, your coding preferences are this, your tasks are this, this is what you eat, this is what you enjoy. And that's like the RLIF end of it, the top-down version of it. And the bottom-up version is basically optimization of GPT OSS 120B on your local hardware. So further quantization will obviously make the model tinier based on your specific tasks, but that's eventual.
Yeah, and I'm wondering, I feel like there's a way to be able to do like GPU scheduling alongside model architecture optimizations, right? Because like if you have enough VRAM to apply this to a Gemma right now, and you want to explore the effectiveness of different quants or different model architectures, like Kimi with kind of their heavy experts, few heads kind of strategy, and then you could see sort of you could end up, rather than getting that one to approve, you could get five to approve, and then the five all have sort of different architectures. You get a Llama, you get a Gemma, you got et cetera, et cetera. It could be very
Correct.
a lot of possibility there. It's really cool.
Yes. That's the reason why Banter Packs or like this infrastructure architecture has a full ELK observability with Prometheus, Grafana, and Jaeger for tracing like what's going wrong if the agents are deployed. So anything that agent does is tracked. Any sort of API calls happen, they are tracked. And that's why the MLOps platform also has a Prometheus plus Grafana, not Prometheus plus Grafana, NSYNC monitoring plus Prometheus Grafana monitoring. I didn't go full ELK there. So for the more like pro-coded people, it's already there.
Yeah, I would presume that the GPU scheduler, that level of orchestration, if that's getting logged alongside the responses, then you should be able to build a good, in addition to your full output data set, you could you stick some probes into the CUDA graph or whatever, and then see what other metrics what other levels you could start making optimizations at. It gets a little fuzzy there, but I think there's some.
Yeah, that's the reason. Like that's why I have Redis for initial logging and Postgres for golden logging, like the ground truth logging. So Postgres handles the actual entire data logging, and Redis is like immediately responding to the cache.
Coming up on the 45th minute, if anyone else in the audience has some questions too, like just a call for questions. I was gonna also ask you about the TTS pipeline. Like, have you played around with the voices and things of that nature, like as Jarvis is responding to you?
Yeah. So basically, my initial take was orchestrating over the API, but I just went the Whisper pipeline. It works for me for now. But because this Whisper pipeline just is pretty simple, I don't need to wire up a lot of things, and it does not require a lot of resources. I was going to try Kitten OS. Have you heard of Kitten OS? Kitten OS is of 25 MB, like TTS pipeline.
No, I haven't.
It was launched last month. It's a very popular, not very popular, but somewhat popular startup on Y Combinator.
I want to post that link, so I'll take some time. Actually, if you got any more questions, I'll take some time and find that and post it.
Let's
Yeah.
see. Kitten, yeah, I would be interested. So you have Whisper for your TTS. What's your STT currently?
Piper.
Oh, Piper. Okay.
Yeah. Whisper Piper pipeline. Yeah.
Hmm.
I did not heavily dive into the entire, like, I had initial success at 80 ms latency. So then I didn't go fully into this level of optimization. Like that front end aspect would come later once I have the entire backend mapped out.
Have you
And the backend is going straight down to the silicon, so it just gets complicated.
Yeah, yeah, I can imagine. Have you have you looked into, or you might have already covered it. I'm not sure. I got was a little late, but multimodality. Have you tried like throwing a moon dream in there and seeing what happens, kind of thing?
I have a plan. Like the this current orchestration has four entire things. Sorry, four. How do I put this? Four repos. The fifth repo is going to be generating comics, more or less. So this discussions that happen, just make them funny and make them into comics.
Hmm.
And then once Sora 2, I have the availability for Sora 2, you'll be able to hear Gemini plus Claude plus GPT-4 discuss it out loud and yelling at my local model to be better.
That sounds like fun.
Yeah, I know.
Fire.
Like it's a good thing.
Yeah.
Eventually, hardware will be good enough, so I could just have at least. I'd presume it would be like a 5 ms lag, but even with 5 ms lag, I could just observe it live animating, like a
You
live
just have
animation of my constitution debate
an
happening.
anime episode about what your GPU kernel is currently doing while you're working. Amazing.
Yes, more or less. It's entertaining. Like I think I like the idea very personally. Like just
Absolutely.
having like an interactive environment where I could just chime in and because obviously I have the voice pipeline ready. So if
Mhm.
I say something and this TTS pipeline is being read by all these models, so I'm actually interacting with anime versions of these guys.
Yeah. Unironically arguing with his kernel because the model's hallucinating again.
Yes.
I love it. That's gonna be a party. Well, and I think there's something to that too in terms of real optimization, right? Because like the kinds of, especially if you get to hear them argue, like I can do a hyperparameter sweep or whatever, but
Mhm.
if we're showing the scheduler this entire like anime episode debate process and being like, okay, now allocate the VRAM, it would be really hard to articulate that in terms of a GPU config. Whatever that thing is sort of like inferring from this sort of blob of data that it's got to work with, I think could be could you could.
Actually, all it has to infer from is what question I have asked and what feedback I'm giving.
Hmm.
So the model itself is like the model allocation is generating, like the system is generating some words. So the TTFT is being allocated, the GPU allocation is just for the model generating words. And the prompt, like whatever prompt I generate, whatever question I asked, that's what it has to observe, nothing else.
Hmm.
This discussion is happening over like on a entirely different thing. But as long as it tracks that my question has 15 tokens, and 15 tokens requires this amount of model resource allocation, partial or full overload. What else needs to be done? Because the scheduler doesn't need to do anything else, or only be dumb enough to simply like this is what you need to do. This is where it needs to be done.
Okay, so
Eventually, when systems get smart enough, I'll have a a smart agent decide. But we are not there yet. Hardware wise, we are not there yet.
yeah, okay, so the VRAM allocation is going to be for sequence level or like batch level kind of
Correct.
token load. Okay,
Correct. Correct. Correct.
interesting. And then I'll put only sequence level pre-allocate it.
To put it simply, all of us work out, right? So the best understanding of this would be, uh, you know how much pressure that you need to put into your muscles to lift a 10 kg dumbbell or a 10 kg bar. But you have to think about your form when you whether you're going to squat with it, whether you're going to bench press with it. But the pressure doesn't change. The muscle allocation doesn't change. All that changes is how you move your muscles. So this RLIF is the thinking part, and the muscle allocation is the GPU scheduler part. Both are independent but related.
Hmm.
Rohit B, did you have a question? I saw you turned your camera on. I don't know if you had a question specifically for Sahil. But I have a couple of questions, if not.
No, it was by mistake. Sorry. Yeah.
Oh, okay, okay. No worries, no worries, no worries. I just wanted to, make sure we include. Is this your Sahil, is this your first like I guess shot or not shot, but like attempt at getting exposure to these ideas in your research? Like this specifically, the Jarvis thing?
Yes, like it was very random. If you see the first commit that I have is extremely quite it's extremely stupid, honestly.
Are you do you have any like the labs? I don't know what your dream job is because that's kind of how we started the conversation, but have any labs reached out for you to do this type of research or AI research, ML research in general, based on your degree or anything that you're interested in doing?
I have applied, but the recent H1B debacle, I my interviews got put on hold, so I just decided why wait?
Yeah,
I'd
yeah.
much rather work.
No, for sure, for sure. So okay, ideally, what is your dream job? Like, do you have any in mind?
I mean, eventually I might end up as a founder, given the scope of my capacity at Muse. But this was my first commit.
Got it. Okay. Yeah, and I'm asking like these type of questions because I think platforms like this, I don't know if you know, but all the recordings go on YouTube. And like there's obviously like the latent space, or let me not say obviously because I'm not sure if everyone here is familiar, but Swix hosts the Latent Space podcast, which is like a huge platform with a lot of subscribers. And this recording actually goes on like Latent Space TV, which is kind of like an associated YouTube channel, but gets a couple hundred views per video. And I'm asking these questions because I'm also curious. Like, do you have a video of you, a demo of you like using Jarvis in action?
I do plan on creating one, but this RLIF pipeline got really interesting, so I'm currently working on that.
Yeah, okay, okay, I understand. I understand.
Like I had a Tauri UI test run.
Yeah.
It is giving me issues, but I'll figure that out.
Yeah, for sure. Yeah, I just think this is really interesting research and obviously like could open you up to lots of job opportunities in my opinion, especially in this space. So I just think posting videos like this or demos like this and work like this, research like this on these type of communities could get you access to, all kinds of opportunities. So I just wanted to say that like while we have a couple minutes left and there's still room for other people to ask questions, I just wanted to ask those type of questions. I guess number one for the recording that's going to go on YouTube, but number two just kind of for my own curiosity. And
Mhm.
it seems like we have some chats related.
As the Web3 guy in the chat, I can certainly think of like 5 or 6 ways to monetize this like immediately if if one wanted to. But I think a better question perhaps that should be included in the recording is for the experiments that you're doing and the kind of like research that you're looking into. Are there any resource shortages that are the so like you got a 4080, you're kind of compute constrained. Is the constraint here breeding creativity, or are there things where it's like, man, I really wish I had X or Y to test this on, kind of thing, or both?
It's actually both because the thing is, it's an interesting space. If you're
Mhm.
deploying this locally and you can have a live system, like the eventual pathway that I have is to have a fully integrated house. So if you've seen any of the Iron Man movies,
For sure.
you
Yep.
have a AR VR system that you can interact with and do whatever you want.
Yep.
And if you have a GPU powerful enough to handle that, this system already enables it.
And
Yeah.
the world models are just getting better.
Yep.
Yeah.
Yeah.
Yep.
Like
Yeah.
like more people are working on model optimization. I'm creating a platform that can plug in any model and optimize it for your local system.
Yeah, I have a lot of I have a very like kind of similar vein project, except I went a lot uh uh I went for the big guys. I was like, okay, let's assume that we don't have any compute constraints, and then we have a coding task. What are what's the best selection of coding models, best selection of coding LoRa's, and then best amount of like kernel level optimizations that we could make to each pipeline kind of thing. But the sort of online kind of constitution building of the golden data set is a very like interesting approach that's kind of cool that it works sort of at any level of or yeah, have you tried scaling it up at all, I guess?
I
Like in
have tried,
principle it's good, but
but my system decided to be SOD then, so I just decided to stop. Like you see, these are the kind of optimization that run. Like if you are looking at the screen, it's everything end to end. So there is a pipeline that is ready for enterprise. Basically, just deploy it over any sort of local multi GPU system. Optimize your LLM to run over that local GPU system and see how it eventually ends up. Everything from yeah, pretty much checkpointing. Yeah.
yeah, I think there's a company that I know that's like actively looking for people to give compute to. I'll see if I can grab the link. Because I think it would be cool to try this on like 8x H100 and just see how far it rips. Right?
Yes, sir. Yeah. Yep.
Yeah, it does. Like you start to see, right? The idea is really interesting. And the more I dive into it, the more interesting it gets.
Yep.
And that's why everything has to be, it's well organized, but yeah, more or less.
This is kind of like a full circle moment for me because like one of the reasons why I got into the AI space a couple years ago is I saw a guy on YouTube trying to build Jarvis, but it was nowhere near this advanced. So it's funny to see something like this kind of like come to fruition. I'm also curious, are you on I saw you had GitHub. I should probably go look at your profile, but are you on Twitter as well?
No, I'm not on Twitter. I did open an account. I should like get active on it, but I'm
Yeah.
working on this. So I like basically I spend at least 10 to 12 hours a day just running through this and seeing where it goes. Like yesterday, yeah, pretty much. And like these tests also run a lot. So I don't spend much time on social media more or less. I had
Yeah.
an automated pipeline. So what ends up happening is
Exactly. Yep.
like the CI/CD for this Banter Packs is this here. So this publishes into Banter logs, which publishes onto my LinkedIn. But that's
Nice.
about it. And to maintain to maintain the code base, I have like a full CI/CD pipeline.
Yeah, I got 16 gigabytes of VRAM at home. I would totally do a demo video for this and like because I just think I can see it going viral in the spaces that are interested in things like that. And we have like 2 minutes left, so we probably have to
Yeah.
ask some wrapping up questions.
Mhm.
But yes, there's like a subreddit called Local Llama, and then an Twitter community called Local Llama that would eat stuff like this up. Like they absolutely love running on GPUs at home. That's the primary focus of those communities. So I think they would love stuff like this. Speaking of communities, if you guys don't have any other parting questions, or Sahil, if you have a request or any questions for us, or any calls to the public that may see this video on YouTube, if you have any like closing comments.
Honestly, anyone who wants to tweak around with this and have fun discussing this, please contact me. Let's have fun.
Perfect, perfect. And if anyone else left on the call, Yax, if you don't have anything to close, basically, what K-Ball normally does at this time is say like, on a weekly basis, we meet on Fridays at this time and kind of like try and discuss interesting ideas in the AI space. So if you have any interesting ideas and would love to sign up for any of the following weeks, please let us know. We typically coordinate in Discord. So the AI in Action Builders channel is the Discord where we kind of get together and you can talk to our AI in Action bot, which will help you schedule for an upcoming week. And we're looking for people to speak. I think the next we have somebody maybe 2 weeks from now, but other than that, it's
2 weeks
like
from now,
a
yeah, I
fairly
was gonna say, yeah, we have an open slot next week. So if you're watching this and it's not next Friday, which is the 24th, I think.
yeah.
Then come to latent.space/p/community and then come to the Discord and tell us that you want to present something. The other addendum that I'll make is for Sahil and then anybody else who is experimenting on a level where they need GPUs. I just dropped a link into the AI in Action channel from a company called Illume. and they are actively trying to give away compute right now. So there's a form to fill out if you click the link that is found in that Discord and perhaps in the show notes. We'll see.
Cool. It's a minute over, so we'll wrap it up. Thank you, Sahil, for presenting. This was really cool, like very interesting. When you said